Okay, what'd you guys find? What's going on in the first one? Limit definition of a derivative. What do you think is one of the most common mistakes I see when I try to test or quiz like on a forever request or a forever final? Coming the week after spring break. All of spring break, most of the homework, the only regular credit homework is going to be quoting the Forever's Life Christmas Break. Everything else is going to be bonus. We'll talk about it more in depth tomorrow. We'll kind of just get into laying the foundation today. But I am going to show you on the website tomorrow real quick in the beginning of class. I'm posting bonus exams underneath your AP exam review. There are practice exams from all sorts of different study guides, study books, study this, study that, and the other. There are the old format, which means 2 fewer questions, not calculator multiple choice, 2 more questions, calculator multiple choice, but the same as that, basically the same. If you guys work through on your own, print it out, work it through, and grade it. This is available up until basically 2 days before the AP exam, because the night before the AP exam, I don't want you doing any of this cramming, doing practice exam stuff. It's not going to help at that point. It's going to cloud your mind and confuse you for the next day. But if you print out on your own initiative, try, attempt, grade, multiple choice portions of the practice exams, you're going to get bonus pushed straight into your test quiz category. And if you try a year's free response from the College Board, I want you to try any of the practice exams free response. As I said, it just doesn't compare to the actual AP. But if you print out and try an old year's free response, that's 1 through 6, attempt it, grade it, and then turn it in. And it's going to be, you can turn it into the back whenever you want, whenever you have it ready. I'll grade it and I'll get it back to you ASAP kind of thing. That will also add bonus. But it has to be all one entire set. That if you just do a couple questions, it's not going to really add anything. We'll go over the details tomorrow. But there are tons of practice AP stuff out there. But one of the most common things that I was doing a quick recap, one of the most common things I see that kids forget is, what is this? Just f prime of a function. Whenever you see that notation, it's just f prime of a function. That's what most kids forget whenever I ask it on a forever quiz or quest. They forget to put f prime equals. They forget to put f prime equals. So if you see the limit definition, you don't have to solve it as a limit. You can try to solve it as a derivative with a derivative rule. On the next page, this is the derivative at a point, right? Once again, some kids realize that this is a definition of a derivative, but you don't necessarily have to solve something that looks in that form like a limit. Once again, if you can figure out who f is and figure out who a is, you can take the derivative of f and plug in a and solve without ever having to do the limit. They're talking about graphically, what it looks like, etc. We're not going to go through all that. What's going on this page? It's the first page of examples, right? What's this reviewing? Continuity, right? At the very first limit as x approaches a, we instead in our forever card, I think we say c, right? At the c exists, same thing. Limit as x approaches c if f of x exists, and they agree. Then they give us a piecewise function. Oh, those AP guys and the piecewise function. How did you guys think about figuring out whether or not this was continuous? What do we do? We gotta take the two-sided limits, right? So take the two-sided limits, then we go ahead and kind of thinking about our theorem. F of a exists, but what are they saying a is equal to? 2. So if we're trying to say f of a would be, in this case, does f of a exist? To answer that question, we have to ask ourselves the question, what is f of 2? You see the or equal to, right? Plug it in, and what did they already figure out f of 2 is equal to? Okay. What's the next step showing you? From the left and from the right, but some of you are like, I don't know how they got those numbers. From the left, are 2 on like a number line, right? Aren't the numbers a little bit lower than? Like 1, 1.9, 1.99999? Which one, which piece of my piecewise are we going to plug into for 1.99999? The less than version, right? So it might be good for you guys just to write yourself a little note to remind yourself, hey, the limit as x approaches to negative at f of x, I'm plugging into x squared plus 3. Because that's the less than inequality. When you plug into that one, you get, just like you did right up above, 7, right? So what piece of the piecewise did you guys plug in, or should you have thought of plugging in for coming from 2 above 2?
The bottom.
The bottom, because it's greater than 2.1, 2.0. So you're plugging into 3x plus 2. 3 times 2 is 6, 6 plus 2 is what they showed it to be at the bottom. Why is the answer that the function is not continuous?
One side of the
So one side of the limits do not agree. The one side of the limits do not agree. The limit does not exist. Like mean girls all over again. Any quick questions on how to test for continuity? Try to plug into both pieces, right? If it's coming from below and above. Hopefully we'll see another example of one that's not equal to and equal to as we keep going. Okay, what was the next page reviewing real quick? Now they give you lots of material. Maybe you guys weren't able to read through it all, but it is a quick summary. The forever cards are the shortest summary of the most important things kids tend to forget. The notes are the much longer worked out version of each topic individually that we did during the year, like a day, 2, 3 days on each topic. This is kind of an in-between. So limits to infinity. I like how they said, examine the x with the largest exponent. They're talking about check the highest degree. And then I love how they say the x with the largest exponent or the heaviest, the greatest degree will carry the weight of the function. It will carry the rest. It's a great way of thinking about it. That's why we just take the highest. So you guys give me the reason why, whether using a degree test or don't just say what they said. But for the first one, why was the limit equal to 0? Bottom's carrying the weight of the bottom limit. Right? Denominator is growing faster. Fast the limit is equal to 0. How about the second case? Why was it positive infinity? Okay, but that's not enough as to why it's positive. The top does win when we look at it as far as the degree, right? Looking at the highest of each. But why is it a positive infinity?
Because
Remember, fuzzy math.
it's growing faster.
Yeah, if you plug in 3 plus, and if you just think about the highest degree, it'd be positive infinity to the fifth, which is going to be a positive number, right? Over, and then when we have positive infinity squared, technically we do it that way. Wouldn't that also be a positive? I'm showing that because every now and then they might give you an expression that when you work it out, it might be a negative infinity. I would hate for you guys just to jump to infinity and not realize maybe there was a negative that was positive. But either way, whenever the top wins, it's an infinite answer for sure. It's an infinite answer for sure. They keep talking about the algebraic reason as to why, and that's good and all, but we'll keep going. What's going on in the bottom one, the degree test? They're tied. And technically, I would still say check the sign if we said in notes. Maybe you remember that, maybe you don't. I would still say check the sign, but when we plug in a positive infinity to the top and the bottom, we do end up with a positive over a positive, hence why we have the ratio of the leading coefficients. Amazing full of sand. That's really intense. Good stuff there. Ready to keep going? Okay. So, how can you summarize this entire page, kind of? I would say degree tests, right? Degree tests. What kinds of limits? Yeah, limits to infinity. However, from your when you see, you think, what is one type of question that should have you thinking infinite, limits to infinity, even if they don't explicitly say it? What kind of question always asks for limits to infinity, but they're not going to say it? Horizontal. At page, degree tests for limits to infinity and horizontal. Okay. What's going on in the last one? One-sided limits. And then we know that the limit as x approaches a constant, right? The limit as x approaches a constant is going to exist if the one-sided limits agree. You guys remember that? The limit as x approaches a constant of a function is going to exist as long as the one-sided limits agree. So in order to think about the limit as x goes to a constant, they say, okay, let's review one-sided limits. So one-sided limits, once again, if it helps you guys for visualizing, c is going to be some arbitrary number. C minus is going to be a number a little lower than. C positive is a number a little bit higher than. And specifically, we're trying to zoom really close into z. We're trying to approach c. Sorry, I said c. So then down below here, that was for our example. And that's when we're approaching 1. What would you guys answer as the one-sided limit as x goes to 1 negative? Does that mean from below or from above? Below. Alright, where are we approaching? Whether or not it's burned down, going back to the diner example from the summer packet. We're approaching 1. Now some of you are like, no, there's a hole. I don't care. The answer is 1 because that's where we are approaching. Right? What would you guys answer for the right-hand limit or the limit from above? 2. This guy is headed towards a diner that actually is there open. He can go in. This guy is headed to the old address. Didn't check yet. But that's okay. He's still headed somewhere. He's not going into like a black hole. The limit as x approaches 1 of f of x, sadly though, your reasoning would be because the one side of limits do not agree. So, you would write D&E, but you probably wouldn't want to just write D&E. You probably want to give some sort of reason as to why. Usually they'll ask you saying justify or explain like you guys have seen. But just in case it's not that, it's just like a simple answer like that, and maybe give a little bit as to why, so it's not just that one thing to agree with. But mostly these questions, for the most part, graphical ones, are going to be multiple choice. I want you to play on this page just with the odds. Huh? Too late? Hey, you can do them all. I say start with the odds, and if you have a little bit extra time, go back to the evens. Every single one of these limits is what kind? Infinite. In the sense that they're not infinite answers per se, but they're approaching infinity. Please think about a mission line. Alright, if you guys finish the odds, try the evens. One thing to you is check the sign. That's like a minutiae one, in the sense of a little thing that the AP might try to trick you on. Beyond the big idea. Check the sign. 0 positive or negative is still 0. Don't need to check him. A ratio of leading coefficients and infinities, better check them. What do you guys think about 5, 6, and 7? A little bit harder? guys check 1, 2, 3, and 4 first. You ready? Bottom wins, tie. Top wins, tie. You guys even get the signs right? Okay. I'm going to ask you about number 5. Any quick questions on 1 through 4? Did you get 6 and 7?
Yeah.
Okay, pause. What's the degree of x squared if he's under a square root? We can't take it. We can't do it. We can't say x minus 3 because that's killing puppy. But we can think about the square root of a quadratic is a linear. So, pi. And what's the coefficient in front of the x squared under the square root? A 1. So technically we would say square root of 1 over 2. But how on earth did I figure out the negative?
It's approaching negative infinity.
If I plug it in, aren't I going to have the square root of negative infinity squared? Remember, these guys don't win. All over 2 times negative infinity. See how they're trying to trick you? What's the sign on the top? Positive. What's the sign on the bottom? So if I have a positive over a negative, what do I have to put in? A negative. On the bottom, it's very similar to the same thing, except this time when you plug in a positive infinity squared, you get a positive, and then 2 times positive infinity is a positive, and so it's positive 1 half. Did anybody figure out how to do number 5? Did you think of L'Hopital's? Because you plug in and don't you get infinity over infinity? No, you don't. Trouble. It's not infinity over infinity. E to the, doesn't e to the go to infinity, guys? Okay. E to the goes to infinity. So as I approach infinity, go to the right. Wouldn't I answer infinity for him? If I was doing fuzzy math. What would I answer for sine of x though? What does he do?
He only goes to positive 1 and 8.
Well, that's a bummer. Doesn't he go between 0 and 1? Oh. So he's. What do you guys think he wins? Why's the bottom win? He's the only one going to infinity. The top is going back and forth between 0 and 1. Long story short, e to the x is much stronger than almost anything. So you can say bottom wins, it's a 0. It's a little weird because it's an unusual 0, but it's a 0 nonetheless. Sarah and Star, quick notes for you. Graduation stuff. You guys keep on going? Questions on this one? It was kind of straightforward, and a little weird, right? What's going on here? What's the limits? Alright, I'm going to freeze the screen. Try the odds first. These are good. Just trying to give you guys this sample. over 0 ones? I haven't answered them on purpose. Well, I guess I did answer the first two. This one's technically going to end up equaling negative. What's going on? 8 was easy plug-in if you did it. 9 could have factored and crossed out, or you could have done L'Hopital's, which says take the derivative of the top and the derivative of the bottom and then try again. But only when you have an indeterminate form. But as soon as you get to 10 and 11, and technically 12 and 13, each of them number over 0, they're technically called infinite forms. Not indeterminate forms, that's 0 over 0, but they're infinite forms. In our notes I said infinite forms, check the sign. It's going to be an infinity. Check the sign. So number 10 says 2 from what? Below. So to check the sign, I would say 3 over something below 2 is 1.9. Kiddos, if you do 1.9 minus 2, if you do 1.99 minus 2, if you do 1.999 minus 2, what do you get? A positive over a negative is a negative. Negative. Now, the other one, 2 from above. Something from above is what? 2.1? Isn't that going to be a positive over a positive, which is a positive? So why on earth did I say on number 12 the limit does not exist?
Because the first one approaching negative.
Yeah, the first two don't agree. So in number 13, how would you guys test number 13? Yeah, you would plug in 2 from above is like 2.1. That sounds good. So 2 minus 2.1. I'm going to have a positive over, what's 2.1 minus, sorry, 2 minus 2.1? Negative. Which is that? Let's see why I put that up. The key to 14 and 15 were, do you know your? Okay, the bell's about to ring. Here's what I want you guys to do. What we haven't gotten to are the multiple choice at the end. So I want you guys to go ahead and, I said at the back, attempt and grade. The minimum is attempting the odds and grading the odds using the answer key online. So it will be called Laying the Foundation Review 1.
Is this one talking?
The minimum is to try the odds, attempt and grade the odds. If you have that